Boom. What you just saw isn't a mini car accident on my desk. It's actually perfectly demonstrate the Newton's second law of motion. So we are going to simply use a marble and a plastic cup and a ruler to unpack the famous formula of Newton, that is F is equal to ma. So in this system the marbles rolls down, accelerate due to gravity and create into the cup. Did you see it? Now, the distance the cup slides tell us exactly how much the force was transferred during the collision, right? First look at the formula F is equal to ma. Okay, by rearranging it, we can write A is equal to F by m. Newton says that acceleration is directly proportional to the force. Means if you increase the unbalanced external force to the given object, then acceleration of that object also increase. Understood? Increase the force to that object, acceleration of that object also increases. Now acceleration is second part of the formula. Acceleration is inversely proportional to the mass. Okay, means if you increase the mass of that object being pushed, it resists accelerating. Means if you have two objects, one is heavier than other, then the lighter object has more acceleration. Condition is force must be constant with the two objects. Okay, so this is the simple setup. You saw this is the ramp, this is the paper cup, there are two rulers, and this is the book. You saw this is for height. Okay, and there are two ball, one is marble, one is steel ball. So how can we prove F is equal to ma by this setup? First of all, more force means more acceleration. How can we generate more force? By simply replacing the marble with the steel ball. Obviously we know that more mass generate more force, more impact. Okay, so we know that more force is can be created by more mass. But how can we measure the acceleration of the cup? Okay, so I hope you can see the full setup properly. First we have to collide the cup with the marble. Okay, when we collide the marble with the cup, we will watch the displacement of the cup and at what time it displaced from 0 to how much centimeter. Okay, we have the watch, we have to see both. Okay, we have to be sharp. Okay, and then again same procedure we have to do with the steel ball. Okay, so first we have to do with the marble. Let's see. Okay, 1 second, 1 second and 5.5, 5.5, 5.5 centimeter. It travels in 5.5 centimeter, 5.5 in 1 second. Okay, 1 second. You know the formula A is equal to 2s by t square. Okay, so how can we calculate? Displacement is centimeter, we have to convert into meter. So 5.5 multiply divide by 100, so 0.055. Okay, divide by 1 second. So the acceleration is 0.055 meter per second square. Now we have to do it with the marble. So it's 10.5 centimeter in 1 second. okay, in 1 second. So 10.5 centimeter we have to convert into meter, so 0.110, okay, by 1, and a square you can do it, okay. So answer is 0.10 meter per second square. So it is obviously greater. So when we collide the cup with the steel ball, it has more acceleration, okay. In the second part we have to prove that mass is inversely proportional to the acceleration. Means if we add the mass to this cup and we keep the marble only, okay, we have to collide the marble with this cup first, then we add mass to this cup. So let's see what is the acceleration in the both scenarios, okay. So first, simple, without without putting mass to the cup, let's see. Always keep your eyes on the watch. So it's 6 centimeter, okay, in 1 second. Now we have to put mass to the cup. How can we have two coins like object, okay, we have to put in the cup. So we are adding mass to the cup. Let's see what will. Now this is, we add the mass, okay. Now we have to collide the same marble, okay, do not change the marble, same mass. Let's see, only 1 centimeter. So without calculation, even without calculation, I can say when we add mass to the cup and we collide with the same marble, it doesn't go beyond 6 centimeter, okay. It means more mass, more mass, less acceleration. Hey, I hope you like my experiments. Please keep in your mind that I measure acceleration without accelerometer, with just pen and paper. If you like my videos, please subscribe my channel Physics Element. I'll keep you updated more and more. Thank you so much.